What's up? What's good? Algebra 2. How you doing? We are looking at Unit 10, and we are continuing to look at trig stuff. Lesson 10.1. Appreciate your time. Thanks for watching. We're looking at the graphs of sine and cosine. Okay? So we can graph these functions. Just like any other function, you can plot it on a graph. And let's take a look. So I'm going to go ahead and look at this. There's this really cool, I can give you this link, or maybe I'll post it on Canvas. This like interactive tool so you can see the graph. The blue is cosine and the green is sine. So I've got the unit circle pulled up over here as well. We know that, sine of 30 is a half, and sine of 45 is root 2 over 2. And when you go to plot those points on a graph, it makes a curve because sine starts out really small at 0. You see how the green line starts at the very bottom? Okay? And then as the y value increases, that's why the green hump is going up. And then at 90 degrees, or pi over 2, we hit that value of 1. But then as we continue on, it starts to descend back down, and then at pi, or 180 degrees, it's at 0 again. You can see those values over here on the unit circle. I have this pulled up at the same time for a reason, to remind you of that, right? That it goes, the sine value increases to 1 at pi over 2. I know my webcam's slightly covering it, but right there, and then it descends back down, root 2, a half, 0, okay? And then it gets into the negative. So as you see here, as I go past 180, that curve starts to go down, and at 270, or 3 pi over 2, it's at -1, as you can see here over on the unit circle, and then it starts to descend back upwards as it gets closer and gets back to 0, okay? And then after a full 360, it just goes and does it again. And the exact opposite is true for cosine, right? Cosine starts out as 1 and then gets smaller and then gets bigger again, right? So that's why the hump is starting at the tippy top. You'll notice that the humps look almost exactly the same, except, cosine starts out high and then goes down, whereas cosine starts in the middle, goes up, and then down, okay? And at 45 degrees, we know that they're the same, right? So you see where they're crossing? They're crossing at 45 degrees, or in radians, pi over 4. And then they're crossing again right here. They're crossing. And then, or not there, sorry, because cosine's negative, right? And sine is positive. But they cross again down here when they're both negative root 2 over 2. And then, so I hope you see where that's coming from. I know I just dwelled on this image for what looks like about 3 minutes, but I want you to understand this curve and why this repetitive motion makes sense. Because now when I go ahead and pull this up on Desmos and plot something like sine of x, you can see it's just repetitive. It's hitting that max. Let's turn this into radians. Okay. It's hitting that max at pi over 2, and then it's back down to 0, and then it's at -1. That makes sense according to the unit circle that we've been looking at over and over. And here's cosine of x, just like so. Let's hide that for a moment. So what can we do to sine of x? So there are some buzzwords here that we've got in this picture. The height of the hump, okay? So here's the middle, right? So let me draw the line y equals 0, okay? This green line is going through the middle of the function, correct? This distance from the green line to the highest point, this distance is a distance of 1, and we call that the amplitude of the function. We call that the amplitude. So we can increase that amplitude by putting a number out in front, because we're vertically stretching it. That is a transformation. That's a transformation vocab that we're used to. A vertical stretch. Or I can make this a number less than 1 and shrink it down. So whatever that number is out in front, that becomes the amplitude. And I can make this as tall as I want. It's still going to curve back and forth, but because I'm multiplying it by 4, I have stretched it up to 4. Or I can shrink it down really slim if I do 0.25, for example. Okay? As you can see, though, this function goes on forever to the right, forever to the left, but it doesn't go forever up or forever down. It's in a very confined space. Let's get rid of the 0.25. It's in a very confined space. It only goes as high as you let it, okay? But it's going to go on infinitely. So let's take a look at our actual notes here and fill in some of these blanks. Because it's going forever to the left and forever to the right, the function has a domain of all reals. However, the range, it's only going to bob up and down between -1 and 1. And I should use brackets because it will touch. Okay? And this is -1 to 1 as well. So cosine and sine are eerily similar, because they're based off that same unit circle. And when you plot, if you were to plot these by hand, I know most of you will probably be using Desmos, but it is nice to know, that sine of 0 is at 0, sine of 90 degrees or pi over 2 is 1, and then it goes back down to 0, and then it goes to -1, and then it goes to 1. That is what we know based on the unit circle. And then cosine starts at 1 and then descends down to 0 to the -1 and then back up. Okay? So it still has this similar curving nature, just in a different order. There's that word amplitude, and you can see there it's that distance. So the A value will always tell you your amplitude. It is the vertical stretch, but more specifically, it is your amplitude. Vertical stretch or shrink. So graph the following trig functions. So 3 sine x. We know that this function is going to, do its thing here. The graph you always want to have 0, pi over 2, pi, 3 pi over 2, and 2 pi. That's just what makes sense because of our unit circle. Open up a unit circle again if you need to, right? Here's our unit circle. 0, pi over 2, pi, 3 pi over. Those are the big hitters. And then you've got all these ones in between, but they get a little bit messier. But the numbers at 0, pi over 2, pi, those are the nice numbers, right? 0 and 1 and -1. Those are the nice numbers. So we like nice numbers, okay? So if we are multiplying it by 3, the sine function is going to do what it always does. It's going to start at 0, but now it's going to go up to 3, back down to 0, down to -3, back up to 0. Okay? And when you look at a unit circle, that makes sense. It starts at 0. And then it goes up to 1, but we're multiplying by 3, so it goes up to 3, back down to 0, then down to -3, and then back to 0. Okay? So these graphs really aren't that bad. We've got a half cosine. What's that going to do? It's just going to make it slimmer. Okay? It's always these same 0, pi over 2, pi, 3 pi over 2, 2 pi. And it's just going to make it slimmer. It's going to start not at 1, but at a half. Goes down to 0. And it's not going to go down to -1, but instead a half. So on and so forth. Oops, I got a little ahead of myself there. Sorry. That's where the 0 is. Then -1/2. Then back to 0. Then back to +1/2. So it's just slimmed it down. It's shrunk it. What do you think? Here's some options on screen. Here's my first question. What do you think's going to happen when we have negative a fourth? What do you think will happen to our function with a negative 1/4 out in front? Well, I hope you took a good educated guess and said that it's going to flip, because that's what it's done for every single other function we've ever graphed together. A negative value out in front will flip it. So where the sine function, typically goes, 0 to 1 to 0 to 1 and then back to 0, it does this. That's what it typically does. Well, now it is flipped. So yes, it's going to start here, but we're going to go down at the start, and the 1/4 shrinks us, so we're not going to go down very far at all. Maybe right there, down a fourth. Let's pretend that's a fourth, okay? And then to 0, and then up, and then to 0. So it's the same function except flipped and shrunk. And you can plug all of this into Desmos, of course, right? But I think it's good to be able to look at something offhand and know what's going to happen. So if I just simply type negative sine of x, you can see there how it's flipped it completely. It's just doing the opposite of what the red function's doing. And then when I type a fourth in, slimmed it down a lot. Okay? I'm going to try to keep this short here. Obviously, I mean, it's getting a little repetitive already. But how about I ask another question? Tell me, what's going to happen to this function? Some answers are going to pop on screen, and you tell me the best description, okay? So, I typed something out. I don't know what I'm going to type yet, but you should have chose the option that said something like it's going to flip and stretch, okay? Something like that, flip and stretch. And because it's cosine, cosine starts at positive 1, then, positive 1, then goes to 0, then negative 1, like this, right? That's what it usually does, okay? But now we have flipped it, so it's going to go down and down all the way to negative 4, and then go to 0, and then up to positive 1, 2, 3, 4, back down like that. So it looks all like that. Almost kind of looks like a parabola if you zoom in like that. It's not a parabola, but kind of looks like it. So here's some great questions to ask. We are given the function, and you have to write it. Okay, we are given the picture of the function, the graph of the function, and we have to write the equation. Okay, so what's our amplitude? Well, remember, amplitude is not like from the high to the low. Okay, that's an easy mistake. You might want to say that the amplitude is like 6 here. 1, 2, 3, 4, 5, 6. But amplitude is, if we split it down the middle, how tall are each of these humps? They're each 3 apiece. So our amplitude is 3. Okay, from high to low, the distance between them is 6, but it's about, if we split it down the middle. And what does that mean? Well, this is a sine function, and our amplitude is 3, so the function would look something like that. Now, keep your eyes peeled as we go through these for where it might be flipped. It might be flipped, and we might need to write negative 3 instead. Let's keep going. Some options pop up on screen here. It's not exact, but I think you can eyeball it. What do you think what can you tell here? What is the amplitude of this function? And also tell me, is it sine? Oh, it says cosine, my bad. So tell me what the amplitude is. So you hopefully chose about 2.5. Would you say, right? Here's 2, here's 3, somewhere in the middle, 2.5, or you could write it as 5 halves. So our equation would look something like that. Did it flip? No, because it's starting out positive. It wouldn't start positive if it was flipped. Okay, it would start in the negatives. Okay, so how about I just have you I'm going to have some options on screen, and you tell me what is the equation of this function. Let's just get straight to the point. What is the equation of this function? So you need to observe what the amplitude is, notice that it's sine, and tell me what is the equation of this function here. Okay? Some options pop up on screen. So what did you observe? You hopefully observed that the amplitude is 1.5. Or you can write it as 3/2. And then the one I gave you here, it's flipped because it's going down. So we know this has been flipped. So this is -3/2 sine of x. So that flip forces it to go downwards. And lastly, oh, we made this a quick one. What are we looking at here? How about you just write it one more time? Observe the amplitude and write the function correctly. Some answers pop up on screen. Okay, so what did you observe? You hopefully noticed that, hey, we got an amplitude of 4 that way. And this is cosine, and cosine, again, it just comes down to the unit circle. If I open up the unit circle one more time here, we know that cosine should start at +1 and then get smaller and go to 0. But the thing is, we flip back here, we're starting at -4. So we've been flipped. End of story. And with that, I appreciate your time. 17 sweet minutes of trigonometry. I'll catch you in class. I really appreciate your time. Thanks for watching.